So here we have the equation y equals x squared that we need to graph using the given table of values. So that being said, what this is telling us to do is to take these values of x, substitute them into the given equation for x to find the output value or the value of y. So we're going to take each of these x values, plug them into the equation to find out what the y value is at that value of x. And then we're going to use that information to graph. So first we have y equals -3 to the second power. Now, anytime you plug a number into an equation for x or y or whatever variable, you need to make sure that you use parentheses to make sure that you are properly including the negative or leaving off the negative in some cases. So always make sure that whatever you're substituting in gets parentheses put around it. So right here, we're plugging in for the x, so that's what we put the parentheses around. So -3 to the second power is the same thing as -3 times -3. And -3 times -3 gives us a +9. So the y value when x is -3 is going to be a +9. Then we have -2, so y equals -2 squared. -2 squared is -2 times -2, which gives us a +4. Y equals -1 squared. -1 times -1 is a +1. Y is equal to 0 squared. 0 times 0 is just 0. Y is equal to a +1 squared, while a +1 times a +1 is still a +1. Y equals a +2 squared. +2 times +2 is a +4. And lastly, we have y equals a +3 squared. And +3 times +3 is a +9. So here we have our table of values, and we're going to graph these numbers in just a little bit. But before we do that, I want to talk a little bit about these numbers based on what we've seen in Unit 1. So we had +9, +4, +1, 0, 1, 4, and 9. So we're going to take a look at our differences and see if it reveals anything to us. So for the first difference, from 9 to 4 is a difference of 5. From 4 to 1 is a difference of 3. From 1 to 0 is a difference of 1. From 0 to 1 is a difference of 1. From 1 to 4 is a difference of 3. And from 4 to 9 is a difference of 5. So clearly we don't have a common first difference, which means that linear function is off the table. This is not a linear function, which means when we graph this function, it will not give us the shape of a line. Well, let's check the second difference. From 5 to 3 is 2. From 3 to 1 is 2. From 1 to 1 is 0. From 1 to 3 is 2. And from 3 to 5 is 2. Now remember back in Unit 1 when we talked about the differences, we did look at a table where we got the 0 in the middle. And we're going to leave that 0 off because what that indicates is that this is the vertex of our function. And so the rest of the second differences are all 2. Therefore, this is a common second difference indicating that this is a quadratic function, which is going to give us a parabola. Hence the reason we get this vertex here. So let's see what this looks like on a coordinate plane. So at -3, we have a point at +9. At -2, we have a point at +4. Now remember the table of values, these are all ordered pairs. Don't forget what we're getting when we do this table of values. This is an XY table, so X and Y, X and Y, X and Y. -1, +1, 0, 0, 1, 1, 2, 4, and 3, 9. So that gives us our graph of a parabola. Now, something that we need to do always, anytime we graph a parabola, is always draw our axis of symmetry. And remember, the axis of symmetry is the line that goes through the vertex, separating our parabola into two congruent parts. So I'm going to go ahead and draw my axis of symmetry through my vertex. Now, this axis of symmetry is crossing the x-axis at 0. So the equation here of the axis of symmetry is x equals 0. Now, let's just take a look at a couple more things before we move on. Notice that our vertex is right here at 0, 0. And notice that that point is also the x-intercept. So here's our x-axis, and that's where our graph is crossing the x-axis. Notice that that point is also our y-intercept. Here's our y-intercept, and that is the point where our graph intersects the y-axis. So for this function, that point represents a whole lot of different things. Now this equation, y equals x squared, is the parent function for a quadratic function. Y equals x squared is the simplest quadratic function that there is, with a vertex at 0, 0, an x-intercept is 0, 0, a y-intercept at 0, 0, and our axis of symmetry is also x equals 0. Now, every other parabola that we're going to graph that does not look like this starts as the parent function. So from the parent function, we can then shift our vertex to the left, to the right, up or down. We can make our parabola wider or narrower depending on the behavior of the equation. And we're going to talk more about that as time comes. So we will see parabolas that are wider. We'll see parabolas that are narrower. We'll see parabolas that actually reflect and will therefore open in the downward direction. But again, all of these parabolas start with the parent function, and from there, depending on what happens to the equation, could have this behavior. So let's take a look at another one. But before we do that, let's go ahead and add some toolbox items to our first guided practice problem. Not what I wanted to do. Okay, so first thing is to use the table for the x values. So you have to be given those x values. You will then take those x values, plug the x values in to find the y values. So we have to substitute those x values into the equation for x, and then we get our output, which is the y values. We will then plot those points on the graph. Always make sure you draw the axis of symmetry. Now, something else that is not typed in here that you definitely need to make sure that you add is to make sure that you're putting parentheses around the numbers that you're plugging into the functions. So for GP1B, we are doing the same thing we just did for 1A, only our equation looks slightly different here. So notice in this case, we now have this negative out in front of the x squared, so we have to be careful when we plug our x values in to make sure that we're properly following the order of operations. So same steps as GP1A, we're going to take our x values and we're going to plug them in to our equation to get our output or y values. So first we have y equals a negative parentheses. Remember, we always put parentheses around the number we're plugging in. This is a -3 to the second power. Now recall the order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. And remember that the multiplication, division come at the same step, and the addition, subtraction come at the same step, but we work those out in order from left to right, depending on if they're both in the equation. So that being said, we start with parentheses. Well, inside of the parentheses, we have a -3. So technically, there's no operation occurring within the parentheses, so therefore we can skip to the exponent part of it. Well, we do have an exponent here. So we have to take care of that exponent before we deal with the negative that's out in front. Because remember, that negative out in front is essentially a -1 being multiplied to whatever's inside the parentheses. And that doesn't come until after the exponents. So we have to go ahead and work out the -3 squared. So that's -3 times -3. And that gives us a +9. Now from there, we will then multiply that 9 times the -1, leaving us with a y value of -9. For the next one, we have a negative, parentheses, -2 squared. -2 squared is -2 times -2, which is a +4. And then we multiply that 4 times the -1, giving us a y value of -4. -1 squared. -1 squared is -1 times -1, which gives us a +1. But then we then have to multiply that +1 times the negative, leaving us with a y value of -1. 0 squared is 0. -0 is just 0. 0 does not have a negative or a positive value. Then we have a +1. So +1 squared is 1 times 1, which is 1. Times that -1 gives us a -1. And we have a +2. +2 squared is 2 times 2 is 4. Excuse me, not 2, 4. And 4 times the -1 gives us a -4. And then lastly, we have a +3. 3 squared, 3 times 3 is a +9. Times that -1 is going to give us a -9. Now again, before we go through and graph this equation or graph this function, I want to again take a look at our differences. So here we had -9, -4, -1, 0, 1, -1, sorry, -4, and -9. So from 9 to 4 is the difference of 5. From 4 to 1 is the difference of 3. From 1 to 0 is the difference of 1. 0 to 1 is the difference of 1. 1 to 4 is the difference of 3. And 4 to 9 is the difference of 5. Again, we do not have a common first difference, therefore this is not a linear function, so let's go ahead and take a look at our second differences. From 5 to 3 is 2. From 3 to 1 is 2. From 1 to 1 is 0. From 1 to 3 is 2. And from 3 to 5 is 2. Here we have our vertex and common second difference, giving us again a quadratic function. Now remember, the difference with this one was that we had that negative out in front of the x squared. Well, notice what that did to all of our y values. So what do you think that's going to do to our parabola when we graph it? Well, let's take a look. So if we take the values that we found In the previous step, we now have points at -3, -9, -2, -4, -1, -1, 0, 0, +1, -1, +2, -4, and +3, -9. So our parabola has the same shape as our parent function, only now it's facing in the downward direction. So it has been reflected across the x-axis. Now let's go ahead and include our axis of symmetry. It appears to have the same axis of symmetry as the parent function at x equals 0. We still have the same vertex at 0, 0, the same y-intercept at 0, 0, and the same x-intercept at 0, 0. So the only difference between this function and the parent function was the fact that it was reflected across the x-axis. So let's take a look at a couple of things after we do the toolbox. We already did that for 1A. This is 1B. So for our toolbox, same steps, use your table of values for the x values, plug in the x values to find the y values, plot your points, and draw your axis of symmetry. All right, so let's compare them. So notice here that from the vertex, the next numbers we have are 1, 4, 9. Well, where have we seen these numbers before? These are our first 3 perfect square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9. Well, that's what we're doing here, aren't we, to get those values? 1 squared is 1, 2 squared is 4, 3 squared is 9. So what would be the next number at, say, +4? Well, 4 squared would be 16, 5 squared would be 25, etc., etc. So the numbers that we're getting here, this, what we're going to call the graphing pattern, are the perfect square numbers. Well, how do those relate back to our vertex? Well, here's our vertex at 0, 0. The next point is up 1 over 1 from that vertex. The next point is up 4 over 2 from that vertex. The next point is up 9 over 3 from the vertex. So that's giving us the next points, and those are all our perfect square numbers. Up 1, up 4, up 9, up 16 would be the next one. Well, what about for this one over here? Well, 1 squared is 1, but then we have that negative value. But if we count the distance from the vertex, well, this is down 1 over 1. This is down 4 over 2. This is down 9 over 3. The next one would be down 16 over 4. So that graphing pattern happens to be our perfect square numbers. Now, I want you to keep these numbers in mind as you look at, 1, 4, 9, 16, 25. As you look at the numbers in the homework, I want you to keep these perfect square numbers in mind. And again, these are what we refer to as the graphing pattern